Welcome to video 1.1 Solving Simple Equations. Now I don't really like the word simple in that, but that's the way that the book describes it. In this case, simple meaning just one step. So it might not be simple to go through. You might face challenges sometimes, but it just means that there's one step. So after this lesson and practice in class, you should be able to solve one-step equations by using addition, subtraction, multiplication, or division. When we're taking guided video notes, you need to fill out anything that is missing in your guided notes. For example, I didn't complete the definition for inverse operations. You want to do that. So anything that I write on the screen, you want to be writing down with me. Don't be afraid to pause, rewind, and rewatch anything to catch and make sure that you have a clear understanding of what's going on in the video. So let's get started. Inverse operations are operations that undo each other. We talked about this in class when we were undoing or moving backwards in our patterns. We undid, for example, our class pattern, we added 2 on each side, and we times by 2 to the figure number. So we undid those operations, and we worked our way backwards. Addition and subtraction is one example of inverse operations because they undo each other. If I gave somebody $3 or I added $3 in their hand, the opposite of that would undo that operation, would be taking away or subtracting the $3 from that person. Now they have $0. Okay, so that's what an inverse operation is. Can you think of a second pairing or another pairing of inverse operations? Hopefully you're able to think of multiplication and division. Multiplication and division undo each other. So let's work through some one-step equations, and we're going to keep in mind using these inverse operations. So if I have this variable, so this x value right here, and I'm subtracting 3, so I have some number, and I'm taking away 3, I want to figure out what that number is. So I need to do the opposite of taking away 3. I need to add in 3. I know in the end I'm going to owe $8, but I want to add those 3 back in to figure out what I started off with. So -8 plus 3 gives me -5. So I started out with adding $5, and here's a little mental check for me, or mental math check for me. I started out with owing -$5. That was my answer. I spent 3 more dollars, so in the end I owed $8, or I had a -$8. That's how I can easily check any of my equations. Let's look at number 2. So in number 2, what should we do to solve for k? So again, we have a number adding to 4.8, and it equals 9.2. I want to figure out what this number is. So what number plus 4.8 equals 9.2? To do this, we need to subtract 4.8 from each side. We're going to have to be doing some borrowing here. Remember, we line up our decimals when we are subtracting with decimals, and we are going to do some borrowing so that we can get 4.4 for our k. Again, I could check and say, well, 4 4/10 plus 4 8/10, if I added it together, that would give me 9 2/10. All right, let's look at number 3. So number 3 looks a little different because it has this pi in it. So it says 9 pi plus x plus 11 pi's. I want to know what this x value is, or how much is here. You don't have to worry about this fact that this is a pi. So this pi, if you don't know, is 3.141519. I could keep going and going and going because it's called an irrational number. But it's just saying 9 times that. And this is saying 11 times that. So this is together an irrational number, or a number that goes on and on forever. So instead of giving a decimal number, so about what it is, we leave it with pi. But basically it's the same thing that we're doing up here, so don't be frightened just because it has a pi in it. think about I'm adding something. So what's the inverse of adding something? I'm going to subtract that something. So I'm going to subtract 11 pi. And I'm going to actually think of actual pies instead of the number pi. If I had 9 pies and I wanted to take away 11 pies, I wouldn't have enough. How much would I owe? Well, I would just go 9 minus 11 and get negative 2 pi. So really, you don't have to worry about that pi there. Just kind of ignore it, I guess, and deal with the numbers. So I just went 9 minus 11, got the negative 2, and tucked on a pi at the end. If I were to grab my calculator, and I could round my numbers to get decimal, so this number would be about negative 6.2, not exactly. So it'd be, but it's about there, just so that you get an idea that it's not negative 2, it's actually about negative 6.2. All right, why don't you pause the video and try number 4. See if you can solve for z. All right, welcome back. Hopefully you have attempted number 4. So in this one might look a little different because it says plus a negative 7. So you can think of this a couple different ways. You can think of it as, well, I have to do the opposite of this. So I would subtract a negative 7, or I can think of the opposite of the negative and know that I need a positive. Both are the same thing, so I'm going to write it down both ways. So I could think of minus a negative 7, minus a negative 7. Well, when I have two negatives, a negative and another negative is actually a positive. So the way that I like to think of it is to actually ignore that plus sign and just know that I need to do the opposite of negative 7, and that's adding 7. But whatever makes sense to you is what you need to be doing. So z equals 20. So in a sense, all this is really saying is 20 plus negative 7, so owing $7. I know I owe my friend $7. If I have $20 and I owe my friend $7, I'm only going to have $13. All right, looking at number 5, I have negative 4 times x. So even though it's not written there, I have a little times in between there. And you're going to often see that it is not written next to, just numbers are shoved next to each other, put right next to each other. That means multiplication. So when a letter is next to a number, that means multiplication. Well, we said the inverse of multiplication is division. So we want to divide. I can't just divide by 4 because that's a negative 4, so I need to divide by a negative 4. And I want to make sure that we understand why this undoes it on this case, because over here we have negative 7 plus 7, that's 0, that cancels out. You'll sometimes see me actually do that physical crossing off. And here you have negative 4 divided by negative 4, that's 1. And when I times by 1, that cancels those numbers out. So again, you might see me crossing those numbers off because they cancel each other out. And I would just have x equals negative 9, because 36 divided by negative 4 is negative 9. All right, number 6. We have a fraction in front of the a. Don't let that fraction worry you at all. I'm still multiplying 2/5 times my variable a. So I want to divide by 2/5. Again, we have the same thing on top and bottom, so it cancels each other out. But the other side looks a little tricky. When I take a number and divide by a fraction, it gets a little complicated. So let's go over to the side. If I have a number divided by a fraction, so this is the same way to write what I just wrote over on the left-hand side, we need to remember to I know a lot of people say keep it, change it, flip it. I say that we are multiplying by the reciprocal. So the reciprocal of 2/5 is 5/2. And to multiply fractions, I need to have them both fractions, and I multiply straight across. So I have negative 20 over 2, which is negative 10. Or I could have simplified my fractions when I'm right here and still would have gotten negative 10. So my answer, negative 10, equals A. and I'll give you some assistance in class in order to help you out with fractions on the calculator as well. All right, we've got 2 more problems to do, so let's do number 7 together. This time I have this fraction line. I have m, and this fraction line means divide. So m divided by 7 equals 12. The opposite of dividing by 7 is multiplying by 7. So m equals, and it's 84. I can double check my answer. 84 divided by 7 sure is 12. Okay, why don't you guys pause the video and try number 8. Okay, in number 8, you got to be careful. You got to remember that that negative sign is there. So I like to tuck it with that negative 8. So I might even cancel it out and write it down here. That way I know I'm dividing by a negative 8 and I don't lose that negative sign, because I'm going to times each side by negative 8. I can't times by a positive 8 because that wouldn't get rid of the negative sign. So I get x equals negative 24. All right, so at the end of every lesson, you're going to have to do a summary and a question. So summarize just means tell me in 2 to 3 sentences how to solve one-step equations. So to start you off, you could say, I solve one-step equations by, and tell me how you do that. And you could even talk about, I checked my one-step solution by doing this. There's 2 sentences right there. Okay, and then you're going to have a couple questions that you need to do. So in this case, we have 2 questions that you need to try to solve. All I'm asking is that you try to solve the problems. Give it some kind of attempt. If you are so beyond confusion, first of all, don't be frustrated. Second of all, write something down that you're confused about. That way I know that you at least looked at the problems and thought about the problems and put some attempt into it. So there has to be something on this question part, and there definitely has to be a summary going on here.